Hello there. This is Dr. Frank Appiah, we're leader in agent or e-currents, associate professor at King's College, University of London, Cambridge, doctoral program. This presentation is about multi-agent cogency and what is the nature of agent in a computer. Nature of agent. Now, the nature of agent involves liveness, safety, and fairness. The first agent in the multi-agent cogency will be a rational animal agent. Here, animal agent, I put this with cybernetic methods 3 years ago, 2018-2021, when I filed a work on cybernetic intelligence with Python at Kwame Nkrumah University of Science and Technology, Kumasi, Ghana. This work involves animal communication on cat-mice interaction. The work approach this with the cause-effect technique in modeling interaction of cat-mice interaction with human. There, I programmed this interaction with the database table by tabulating and regulating mechanisms of cat-mice interaction. A question that runs through the discussion is what does make the cat chase mice on sight? In there, there are regulating mechanisms of their regulating body. The rational agent is a rationale. This agent has a set of reasons that plan, decide, and believe that cat-mice interaction is based on a regulating mechanism. This agent stores the plans, decision, and belief as data in more than 6 tables. Rational agent here in bold bulletin is created in C++ scripting, Python to retrieve the data information for display. The second bulletin is a rational animal agent is a console application. The nature of the rational animal agent. This involves liveness and safety. On the second agent is the pure agent. What is a pure agent? It has to do with straight a priori principles. Priori principles to do with temporal evidence. Principles to do with empirical and transcendental evidence. A straight a priori principle. On this, agent in pure sense has a plan to decide happenings before a strict time. Decision or plan happens based on temporal calculus principle. This can be before an elapsed time t1, after an elapsed time t2. It can be always on time, sometimes t, or the difference in time. Now, the decision of plans will come into existence after or before a straight time. Decisions of plans will come into existence always or sometimes. Board bulletin goals of a pure agent will be done in some time t. Board bulletins. Decision of a pure agent is to extinguish fire in a vehicle in a few seconds prior on fire. Decision of pure agent is to extinguish fire in a vehicle in a few seconds pearl with pure water. Decisions of agent is to spray scented perfume in a non-conveyed area after every 30 seconds per light. Now on empirical and transcendental principles. Empirical principles of pure agent is based on scientific evidence rather than on theory. Empirical principles, scientific rather than theory. Transcendental principles of pure agent is based on exponential growth scientific evidence without limit. Here, transcendental principle is free of things that can limit an agent from achieving a plan or rational outcome from its beliefs or goals. Now, the nature of pure agent involves liveness and safety. Nature of pure agent. The third agent is on applied agent. What is this? Well, applied agent is directed to the rule of the use of understanding. This is also called agent governance. Work on applied agent. 2 years ago, which is 2022, 2021, or 2022, at King's London in doctoral program actually granted by the Liverpool of University of Cambridge, King's. I worked on applied agent to the use of economics, business concepts in helping agents in buy, sell decision. The applied agent here is a color console application that brings out screen some store decisions modeled on clean axiomatic rules. The applied agent is developed in C++ by an AND function. I'll talk about this later on. Type theory describes the type system programmed in C++. This is a programming language feature used to reduce bias in program development. And as the library of classes imported into an application development environment. A Mapper project is hosted, that's the project name, hosted at github.com /funhubgt/Mapper. Layout is a type language theory for interpretable artificial intelligence method for multi-agent perspective. Type environment of Lilo's program is made with the library. Now, the library here creates a type environment in an IDE, an integrated development environment, IDE. Also creates an assignment environment in the IDE. This creates also a denotation of judgment of type system looked in the IDE environment. An IDE, okay. Now, the fourth agent is on moral agent. Moral agent for what? That's a question I ask. Merely the necessity of free will under hindrances of feeling, passion, and inclination will be a moral. We need a moral agent. Moral agents are under feeling hindrances. Moral agents under passion hindrance, and then we have moral agent under inclination hindrance. We'll look at that also in more details. During the presentation, which is during the preparation of this presentation, I had an earpiece on listening to Lady Screen by a male singer song in 3 translations from radio. The second song is Slow Down Baby by a male singer. The third song is Love Fever by a female singer. The This is a moral agent and a feeling of affection. These are examples of them. The affective computer, rightly from MIT subject, is a headway in moral agents. This agent is providing a free will and a hindrance of passion and feeling, both passion and feeling. Okay. Moral agent on affection, feeling, and passion. Work done so far by the presenter is to create a heart for love shape, then presenting the power of heart for love shape in several orientations and positions. Then I did apply picture layout techniques, apply color filter processing to create ambient environment on display, and then apply text processing to bring out some meaning to the pictures. That's one way of creating moral agent on affection. Now, moral agent under inclination is a feeling that you want to do something. So how do you use a computer to create a feeling for people to do something? Moral agent is a tendency to behave in a particular way. How do you use a computer to create a moral agent to have people behave in certain ways? How do you do that also to have a certain kind of interest in doing something? So moral agent to have a particular interest and also to be interested in a thing. Okay. Now, when do one need a moral agent? In moody, happy, sad, tired, pain, joy, and more situations. That's the question I asked. But the nature of moral agent involves liveness, and that precisely falls on feeling, safety, passion, and fairness, inclination. The fifth here is cogent. Cogent, what is the nature of an agent? Cogent asks is to address the nature of an agent in general. So one is that we are finding solutions to liveness nature of an agent. So how do you make an agent live long? Okay, so finding solutions to safety nature of an agent also. And the third is finding solution to fairness nature of an agent. Here are the cogent situations, situating cogent to an agent for Lifenet conditions. Another will be situating a cogent to an agent for safety conditions. And the third will be situating a cogent to an agent for fairness conditions, cogent situations. Now, in addressing, we'll look at the linear safety and the third into details. Liveness conditions of here 4 bulletins, 4 numerated or listed points. The first is the transport of a live flag to a connected computer. So you transport flag alive equals true, alive equals true to a connected computer to indicate a live condition for an agent in execution running. Third is display of indicator statements on screen during execution or run state of an agent on computer. The third is on software performance measures that are given as liveness screen front on the computer. The fourth is that the agent is powered by a connected electricity on live wire. That is important. So an agent liveness condition will be to be powered by a connected electricity on live wire. Now on each on the points of linear conditions. Now the liveness, which is the live flags can be displayed on scheduled menu item. In this human-computer interaction, each prior item in the list menu is a source of liveness condition. Each prior item changes the whole graphical user interface. The fourth bulletin, liveness can be repeatedly. New prior item is made to automate the agent liveness. Okay. Now, second is the indicator liveness. Agent should indicate liveness. Yes. Several text information is placed in code to display. In each state of program execution, as indicated on run. The fourth is that liveness is introduced when the text in list display is selected by a timer code in automation. The third is on performance liveness. Live performance can be done on software by profiling the agent. That means that you attach an agent software by monitoring execution points, runtime, memory usage, memory size, and more. Profile.run in C++ and Java profiler agent are both performance liveness conditions to get performance liveness. Now the fourth is the LiveWire liveness. LiveWire situation is by connecting equipment like computer, yes, where the agent runs to electricity supply and have electricity go through it. The powered battery source is also a LiveWire condition. The source can store electricity for some time to cater for any lost electricity line during execution. Now liveness, we're done with liveness conditions. Now is safety conditions. Safe algebra. Now safe algebra are algebraic expressions used to show safe properties of an agent. It's mostly used in database system to create mathematical properties of a table. When do we have a safe safety condition? When we have safe data. Now, an agent is safe in Cogency if the data columns are properly named. It's also safe in Cogency if the data columns are properly ordered. It's safe in Cogency if the data columns are properly typed. Again, it's safe in Cogency if the data columns are properly valued. An agent is saved in Cogency if the database is secured. Agent is saved in Cogency if data is referent with intentional objects. What this means is that if you are doing a select clause and you say maybe name equals Frank, then the referent is the name and then the intentional object is Frank on the select clause. And that's in database. An agent Cogency is all about safe data properties in a computer. Now that we are done with that, the third now is a fairness condition. That's a tricky one, fairness condition. Now, an agent is a computer system with reasons, beliefs, and plans towards the right, means correctness. And a fair agent here is a computer system with morals towards the right. A fair agent is a computer system with large size of beliefs, plans, and reasons on average. That's an important point. So a fair agent, that's reasoning and beliefs and plans, but how large is the size of that belief? And that is important for you to have a fair agent. And a fair agent requires that the user interacts. That is also most important in second to the size. So after you have the size, you need an interaction, user interaction running on a computer. Then the third one, the fair agent uses a mechanism of game theory with win or lose strategy. Okay, so it needs a game theory. Now, an example here is a phenomenon procurement enhanced publication at the Easy Chair number 4495, which I made published. There's a need by an agent to determine a generalized position of a procurement enhanced in an attractive interest or attractive attention. Agent parties are responsible to add by a chain of commands and that create an enhanced game determined to be a win or loss. Now here in this paper, the decision actions are to cooperate or defect. The outcomes are to propose or not. Enact is to propose into law, so just propose doesn't take into law. That's the decision outcome. The decision ratio is an outcome of action. The possible incentive measure will be to propose over cooperate, which is B, propose over defect, or enact over cooperate, or enact over defect. The procurement is based on an effort made by an actor to do business in the agent marketplace, and the chain of command doesn't need to conflict with the resources available to them. Here, the implication of chain of commands. Actors communicate their interests to the other. There's a legalized position insisting each agent pays party knows of each other interests and attentions. Okay. Finally, references for this. The first is on by me an object-oriented language based on C++, Linux type language. The second is on semantic computation proposal, positional model composites and enhanced logic. The third and the fourth are books that I've written, one at Lulu and Amazon. The first book is on cybernetics intelligence. The second is program production, and the final one is simulation profiling at Amazon. Thank you for your time, and this is on multi-agent cogency. What is the nature of agent in a computer? In this presentation, we looked at the nature of the agent in terms of liveness, fairness, safety, liveness, fairness, and safety. Then we looked at 5 different types of multi-agent. And multi means to have different kinds of agent coexisting. So and that is cogency, coexisting, cogency. Okay, so the cogent, which is the main part of which looks a bit new, is to think about finding solutions to liveness nature, finding solutions to safety nature of an agent, finding solutions to fairness nature of an agent, and that situating cogent, which is another agent, to that in those conditions, and providing the conditions for that cogent to situate, to have a site in the same system. We look at Lifenet conditions as in a live flag indicator performance and live wire. I did explain and how to achieve that in the computer system. Safety as safe algebra, meaning having your data columns in a table that properly typed, named, valued, secure database, a referent when intentional objects bring out results. Okay, then the fairness condition, the tricky part is to look at how big, how complex is your agent. database in terms of beliefs, what it plans to do, and what it reasons. How big is that? So how fair is that? Okay, and how fair is a user interaction running a fair agent? And do your agent use mechanisms of game theory with a win or lose strategy? Fairness agent. And I made a reference to a paper to describe such situation. Then that's the final thing. Okay. So that brings me to the end of this presentation. We did look at moral agents. What it means. We look at applied agents using rules, semantic, whether semantic, synthetic rules, computations in understanding, directing understanding, providing an agent governance as applied agents. Then we did look at pure agents that creates agents that have no limits to what they can do with their set of plans or rational outcomes. So that's a transcendental principle, but transcendental based on exponential equation. So the growth of the scientific evidence grows exponentially. The third, that's the third one, the third principle of a pure agent. How do you describe a pure agent? Then the empirical principles of pure agent based on scientific evidence rather than theory. Then some agent goals. And the first was a straight pure principle, which is means strict time for agent to execute and to stop, repeat, that kind of thing. A scheduled agent. That's the second pure agent. Then the first was a rational animal agent. That is I have done a lot of extensive work here. I published almost 4 books here. The looking at normal animal interactions and then tabulating their regulating mechanisms and creating a database of it, their plans, beliefs, and that. And the example here was on cat and mice and the basic principles in there. Thank you for your time and bye. Multi-agent Cogency.